Hi, welcome to Parametric House. In this Rhino Grasshopper tutorial, I want to show you how you can convert a curve into a mesh by defining a series of radius. As you can see here, I can change the radius and produce different results. We're going to also talk about a little bit of an offset we have here. And also we can give this any curve. So if I just draw this in Rhino and set this to the curve, you can see that I can change this. The good thing about the radius is that if I change this to, for example, 2, it's going to define the start and the end. So whatever numbers you add, it's going to just divide the curve into the same amount and then give that to the radius. So we can control that easily. You can also select the curve, move the control points, and as you can see here, I can change the result. And this is going to be the final result. So be sure to watch the video till the end to learn step by step how we can make the final result. Okay, to get started from scratch, what I want to do is to draw a curve in Rhino, for example, and just bring this inside Grasshopper. Go to the Params menu, Geometry Curve, and just set this to the curve. Now we have that in Grasshopper. Okay, the next part is to make the base surface for the mesh. For this tutorial, I have used the surface freeform pipe variable, which is different, a little bit different about pipe, because the pipe variable gives you more control over the radius and you can change that. So if I give this to the curve, let me first explain the most simple way you can use this pipe variable, which is not really the main way you can use it. So I'm going to internalize the curve, delete it. And for example, if I give this a radius, whatever you do, you have to define what is the parameter. So for example, if I give this a 0 and change that, you can see it's going to be a simple pipe. And if I say 0, 1, which is going to be the start and the end, for the panel we have to right click and say multi-line data. You're going to see here that it says you must supply equal amounts of parameters and radius. So the number of radius that you have here, you have to have the same amount for the parameters. So I'm going to just Control-C, Control-V that, use the Shift key, and this is going to go to the start and the end. As you can see here, this is not right. So be sure to right click here and reparameterize it. So it's going to be from 0 to 1. Reparameterizing is going to make the curve start from 0 to 1, which is exactly what we want. And now you can see that you can change that easily. If you change the cap to flat, it's going to give you a solid like this. And if you use the round, it's going to give you a hemisphere at the start and the end, which is exactly what we're going to use in this tutorial. So I wanted to explain this part so you understand that you have to have the same number of radius and parameters for the curve. To make it easier, I'm going to use the Params menu, utility, and a gene pool, or you can find it here, gene pool. This is a bundled number slider, so I'm going to double click this. And for example, say we want to define 3 radiuses from 1 to 20. You can define how many decimals it has, and you can see that this is going to be the start, for example, the mid of the curve, and the end. So if I just give this to the radius, you have to define the same amount of parameters here. Actually, there are lots of ways you can do that, but to make it as easy as possible, I'm going to use a range, or you can find it in sets, sequence range. By default, when we reparameterize the curve from 0 to 1, the domain of the range is between 0 and 1, which is exactly what we need. And we have to define how many steps we need. So let's just count the number of the gene pool. Just go to the sets and use this list length tool here, which measures the length of a list. And as you can see here, it says we have 3, and I give this to the steps. when we divide a domain to the number of steps, it will give us an additional number. So for example, if I divide it to 3, you can see that we have 4 numbers, because for example, if we have 0 and 1 and divide this into 3 equal segments, it's going to be 4 numbers: 0, 0.3, 0.6, and 1. That's why we have 1 additional number. So what we have to do is to say the steps is x minus 1. It means just 1 less than the length. So expression x minus 1, and we give that to the parameter here. Okay, now you can see that we have the start, the mid, and the end. So if you want to also control the parameter, you just have to, for example, make a gene pool here, make it between 0 and 1, give it to the parameter, and remember that start from 0 to 1, and then just move that location if you want to play with the radius. You can see it here. Okay, so that's also possible, but for now, to make it easy, I'm just going to use the range one. Okay, that's how first we make the range, and that's the first step. So let's just make that into a group. Okay, now if I bake this pipe in Rhino, you can see that we have this brep here. What we want to do is to define a box and split with this box and get the top part, right? We don't need the bottom. We just need the top, and we're going to use that to produce the mesh. Okay, to do that, what I usually do is to go to surface and use a bounding box and give it to the pipe. Remember, if you have multiple pipes, you just have to right click here and use the union box, because it's going to make it like union box for all of the objects, but for now per object is fine. And what we have to do is to move it half of the height, right? So I'm going to go to the surface analyzers. For this one, we can do anything. We can just deconstruct the box, find this edge, find the length, divide it by 2, move it down in the z direction, and do that. But to learn another tool here, I've chosen the box corners. So remember that you can do that any method you want. For this one, it's going to give you all the corners of the box. And let's go to the params menu, put a point to the corners. This is going to be the corner A. Obviously, this is B, A, B, C, D, E. So what we need here is an A and E, the length of this. So I'm just going to make a vector and vector 2 point, which makes a vector between 2 points, obviously, and start from E to A, which is going to be in the minus direction, obviously. And also be sure that the unitize is to false, because we don't want a unit vector, we want a real vector. And I'm going to go to the vector and make the expression of x divided by 2, because I want the half of this length. And now we just have to move the box down. Move the box with this vector motion, just turn off everything, and now you can see that you have the box. That's it. And now what we have to do is to split the brep. I'm going to go to the intersection, and let's go to the shape and split the brep. Split the brep is going to be splitting the pipe variable with this cutter. Just bring this down, give it to here. And as you can see here, we have 2 sets of breps. If I bake that, you can have it here. We can actually select list item 0, for example, to work with this. But the problem I want for the future examples is that what if we, for example, just draw a curve here. What if it doesn't bring us the top, and for example the list item 1 is not working? to be sure that always we have the top, there's also another method we can use, and that is using this one. Okay, as you can see here, if you move it too fast for the curve, it's going to intersect. So remember that you have to have a correct curve to get a good result. So I'm going to just play around with this and also make this a little bit smaller so the results is like this. Okay, whatever. And now what I have here is I want to select the top part. Another technique you can use for list item is one of them, is to go to the surface and find the area. Obviously the area of the top is outside this box and the area of the bottom is inside the box. So why not just check it by going to the surface analyzers. And learn lots of tools in this tutorial. So point in brep is also good. We want to test the point inside the moved box, and as you can see here, one is true and another one is false. So what you have to do is to go to the sets list and dispatch. The list you want to dispatch is the splitted parts, and the pattern is going to be the true false we give here. So it's going to bring it into two groups of true and false, and that's it. So I'm going to just give the brep to list A is going to be the bottom and list B is going to be the top. Because it's false, it means it doesn't go inside the box. So that's what we have to do here. That is going to be the second step. And so remember, you can use the list item or use this better solution so you always get the correct result. Okay, now that we have the final result, it's time to convert that into a mesh. I'm going to use the mesh triangulation and this tree or remesh, triangular remesh, and give that to here. The target is going to be the same, so I'll just give that to the target. Sharp is a true and false. You can use a toggle and check if it doesn't change or not based on your project. So let's just say sharp. The features, as you can see here, says additional curves or points to preserve. For this one, what I want to do is to preserve, if I go to the intersection and find the brep plane component, I'm going to intersect the pipe thing with the plane. By default, it's XY. So that's good. And XY plane is going to give you the boundary. We want to say that, keep that, okay? You can also disconnect or connect that if you want to, but this is going to make it sure it gets the best results, okay? And now the length is here, so let's just give that number slider. And the iteration, which by default is 25. It's not really that important, but changing it, for example, 0, you can see it's making it like that. And then as you go up, it brings the final results. Okay, that's all what we have to do here. So remember that, for example, if I want to draw an arc and give it to the curve, and maybe just start from 10 to 20, put the start and the end the same, maybe just make it bigger and the middle a little bit less for the radius. And now you can see that we have made this kind of mesh here easily. What you get here is the triangulation, which is this one. If you want the dual graph, which is really cool. And how it's produced is that if you have the base mesh here, let me explain it. If I can show you the base mesh, let me just take the mesh edges of the dual, so I can explain it here. Okay, if you have a mesh triangulation here, what you have to do is to connect the center to the mid edge, something like that. It has also some additional things that the edge for this one is like straight, because maybe it's going to be broken here, so it's going to make it straight and it will give you the dual graph. So you can do that, use that here. For example, even we can go to the surface and use this multi-pipe, give the naked edges, the interior edges here, and also the naked edges, and the size points. I think that's the node size. That's also cool. And let's go to the rendered mode so you can see that. That's also a good thing if you want to have that in Rhino. Let's turn this off. And if you want the mesh, obviously it's going to be made here. Okay, let's also make the boundary. So what we have to do here is to select the creases, which is going to be the boundary, join them together from the curve join curves, because we want to convert those 57 lines into one. You can use the curve offset tools, so there are two tools you can use. One is offset curve and one is offset curve loose. Whatever you want to choose, and just give this a distance. Plane is obviously X, Y, and if you want to make it smooth, you can use the curve utility and rebuild curve. Rebuild it into degree 3. So I'm going to just give this a degree 3 and a count of 14 to make it more precise. Just increase or decrease that based on your project. And obviously you can just give a surface to this and extrude it down. Surface, freeform, and extrude in the Z direction, but we have to go downwards, so I'm just going to make it -X for the unit vector. And now we can just give this a number slider, and that's it. That's how you can make the extrusion and make the mesh. And that's it. That's how you can make it using these simple tools and algorithm. And it's really easy. You just have to draw the curve you want. Why not just use another one? For example, a spiral flat, and the turns is 1. I think is fine. And just use this one. Okay, we have some problems from the offset. And as you can see here, this offset curve loose is producing this. So if you want to, you can use this offset, simple offset. And then give it to rebuild, increase the number of count. And as you can increase that, you can also make it like this. Let me just give this a custom preview. And one for the mesh. And a swatch. I usually give that for visualization. And if you want to see the mesh edges, a mesh edges is going to be fine. That's it. Okay. So you can see how easy it is to produce a mesh from a curve by using this technique. And remember that the number sliders you produce here is going to define the overall shape. So I'm going to just, okay, for the error here, we can just go here and debug it. The offset is too much maybe. Okay, here that we have a join curve, because for the creases it also has given, let me show you here. This is also a good exercise. It has given also this one. So to fix that, it's really easy. Just have to, instead of creases join curve, you can go to intersection, mathematical, mesh plane. Why not use this one and say intersect this mesh with an XY plane, and that's it. We have the curve, and now we can join them, and always be sure that it's not going to give us an error. So I think debugging is also important, and here we go. Also, if you want to learn how to convert the surface into a parametric building, you can control the offset of the roof, the number of windows, the number of count of the floors. I'm going to explain this step by step. You can check out our website for more information about this lesson. I'm going to put it below the Grasshopper tutorial. Okay, thanks for watching. I hope this tutorial was useful. Remember to like this video and share it with your friends, and see you next time. Bye.